Okay, so we're going to draw diagrams here. So, what types of diagrams are we going to draw for this one? There's only two types. I'll go ahead. Top inside view. Somebody, when I was helping this with somebody, and they said bird's eye view. Okay, and that's okay as well. So this is going to be a top or bird's eye view. Now, this is the thing to remember for this type of question. From the top view, again, assume that you're standing on the top of a mountain or something looking down at Superman. Okay, go with me here, okay? Stay with me. What do you notice if you're looking up from something from very, very tall? What dimensions do you notice? 2D, yes. Okay, but do you notice what? North, south, east, west, up, down? What do you notice if you're looking at something from very high? North, south, east, west is all you're going to notice, okay? So in this case, we're going to have Superman is flying north. So that's going to be 325. Then he's going to go west 40. Okay. Are we okay on the logic for this? Does it make sense why if you're standing in the middle of, if you're standing at heaven looking down, well, you can't see elevation? Does that make sense? Well, just imagine, Chris, if you're, I'm going to do this. If you're looking at this calculator straight on, and this looks like a real calculator. If I do this, you can't tell me how long the calculator is, right? Yeah. You can estimate it, but all you can really see is the left and right component of it, right? You can't see. And imagine something like a meter stick, that would be difficult, right? Like you can only see a little tiny bit of it. Now you can't see any of it. You can only see the left and right part. It's the same idea with this, for north, south, east, west. If you're very up high, you can't see anything with it. In green, I'm going to be the side view. What is the only thing that we can see on the side view? There's only one thing that I can see. Elevation, that's all there is, okay? So my elevation here is going to be 21 degrees.
Do you know what way it is, or is it just like...
It doesn't really matter. I could have drawn the triangle the other way. Right now it'll work fine as well.
So then, if you're looking at it from a bird's eye view, then how are you able to see north? Oh, never mind.
Because you're looking, you know what I mean? Like,
I keep thinking north is like direct.
yeah, I know. Just imagine like you're looking at a map, right? Like
yeah.
You can't see mountains on a map, right?
Yeah.
You can see brown splotches that are supposed to be mountains, but you can't actually tell what they are. This is from the side, so imagine that Mr. Savage throws something from the side, right? But you can't tell if I throw this up from going north, south, east, or west. That's the idea. All right, now here's the thing. I hear lots of whispers in the back. Austin, stay in the zone, please, and Noah. I need you guys in the zone. I had some new knock-knock jokes for you today, in case people were starting to act up, so I forgot. Actually, I got one, but I'm not going to do it yet. I'll wait. Okay, now what's the connected side? This is the key to this question here. What is the connected side? Matt, go ahead.
The hypotenuse of the second one and like 325?
Not quite. Okay, because that's going to be. Go ahead.
The hypotenuse of the blue triangle, and then the bottom side of the green triangle?
Yes. Now let's just talk about why that is. Okay? Again, on the blue triangle, all you can see are things that are horizontal. I'm going to click over this so I can get out of the way. All you can see are things that are horizontal. So the only thing that's horizontal on the green triangle is the bottom. Technically, it would really be up here you'd be seeing, right? Right, because that's really what you'd be seeing because it'd be in the air, but you consider it to be on the ground. So that's what's called the ground velocity. Where is the air velocity going to be? What's the air velocity going to be? Jeff, go ahead.
The hypotenuse of the green triangle?
Yes. Yeah.
The ground velocity has to be
Right on. Yeah, or parallel to the ground, I guess. Not perpendicular. Yeah, parallel to the ground, which makes sense, right? The ground velocity would be.
How do you know that? that's ground in there.
Well, because you're thinking, because the idea is ground has to be horizontal. That's what you're saying.
Alright, how do you do it outside there?
Because that's going to be the plane flying through the air, right? You know what I mean? Like, or the Superman flying through the air is going to be that one, right? Like, again, if you're looking at the ground as Superman, you can't see the hypotenuse, right? You can only see this. Okay, stay with me, guys, please. Go ahead. Of this one, because you're looking because this whole bird's eye view is all. Okay, right. This is you only look at something that's flat, right? So this entire Superman and then the wind is all just horizontal is all it's going to be. So therefore, its resultant is also going to be horizontal. When you're looking at things from the ground, again, it's going to be only the horizontal ones is what I worry about. And the air is going to be this one, so that one's going to be the air. It's a little tricky to visualize here. Yeah, you still fly up, and this is the flying up. This one here. All right, here we go. Let's go here. So if we're looking for a 3D vector, which I'm going to, what are the components of the vector on the left? If we want to break this into components. And I'm going to snub you guys, I'm going to snub Derek, Matt, I'm going to snub you too, since you raised your hand already. Somebody else, what are my components going to be? What's the X component of the blue picture, please? You're snubbed. Sorry, go ahead. I'm going to call it -40, but that works. It's negative goes that way. Right on. Because positive would be the right. Like just written north of, like just like think you're a number line, right?
So that if other than like north would be positive, then right, so that's the big negative.
Okay, can somebody else other than Tori and the rest of the gang, what's my Y coordinate for this going to be, please? Yeah, go ahead. 325. Now this is the key to this question. What's the Z component for the left triangle?
Would it be A?
Yeah, it would be A, but that's going to be on the right triangle. For this blue triangle, it's just going to be 0. Okay? Because there's going to be there's no Z part on the blue triangle. Over here, you're exactly right. Okay, we're going to make this one, and it's still going to be -40, 325, and I'm going to call it just Z, because Z is technically there. That's going to be your Z component is going up in the air. Okay? Are we sort of, is this helping or hurting?
The same side. You said I was like A. You said yeah, but now it's
I just said A, but it's not A. I said A, but I wasn't thinking clearly. Because that is the only, just wait, Bailey, just wait. Because that is the only thing going up in the air, right? You have to think, the only thing going north-south is 325. The only thing going east-west is 40. The only thing going up-down is Z.
But what's up, down, being Y?
In this case, up-down is going to be Z. That's what I'm thinking. Like up-down on a piece of paper, this is the way we're saying it here, okay? On a piece of paper, this is X, this is Y, but I'm assuming this paper is flat then, right? So then Z would be this one here. Okay? So everyone see that, right? Like X, Y, and then Z's going there. All right, let's find some magnitudes. This one on the left should be relatively easy. We'll do the one on the right. How do I find what G is going to be, please? Back from grade 9 or whatever. Go ahead. Yeah.
Square root of A squared plus B squared.
Yeah. So I'm going to say the magnitude of G is going to be the square root of 40 squared plus 325 squared. That's just Pythagorean theorem. If you want to include the plus 0 squared, you may. I can't do this in my head. It's too big. So maybe I'm screwed. 1600. I don't know what 325 squared is. It's a big number. 1 million. Close to 1 million. Oh, do you got it?
Root 327.45.
What's you get for square root? We don't get the square. You just square that. So one more time.
107,225.
1007.
No, 107,225.
That's it. Oh, I thought it was a million. I can't multiply my head. Yeah, 1,000 times 1,000 is a million. Sorry. Okay, does an answer 327.45 make sense to that triangle? Why or why not? Somebody give me a why. Jason, why does that make sense, 327?
Because this one side length is pretty small, and then the other one's like longer.
Yeah.
So then, like, the angle there is going to be small.
Yeah, so the answer I was looking for, that is correct. The answer I was looking for is the hypotenuse, so it's bigger. Works as well too, right? But you're exactly right, the idea it should be just a little bit bigger. Okay? And the one last night was 201 was your hypotenuse or something like that, and this was 200. Okay, so for the right one, we don't actually need to solve for z in this one unless I ask you for the z component. Okay, so now I know that this is 327.45. Somebody please tell me how to solve for a, which is the air velocity. Oh my goodness, Spider-Man's really coming out today. Brendan, you're in the zone. Brendan, solve for a, please. Oh.
Could we do like sine law?
You could use sine law or cosine law. I'm going to use cosine now. Say cosine of 21 equals 327.45 over a. Okay, I'm going to use that because it's the right angle, right? Like you could have used sine law if you wanted to, but because it's the right angle, I'm just going back to SOHCAHTOA. All right, so magnitude of a equals 327.45 over cos 21. I can't do that in my head.
350.7.
350.7, I trust you.
I don't trust you.
Okay, I apologize, Derek, because I said yesterday I didn't trust you with that glass Spider-Man clock, but I trust you with math calculations there. Okay. Did that help at all, or not really? No question?
Can we say that, like, that is actually y? Because, like,
If you want to call it X, Y, Z, they're all relative, right? So yeah, this one. Generally though, because this is flat, I consider this X and Y, right? But I'm not going to penalize you. But if I say, what's the height of the plane? As long as, what's the height of Superman? As long as you give me the right answer, I don't care. You know what I mean? So if you count that as your Y component and I count it as my Z, that's fine. Okay. Did that help at all?
I still don't understand how both of these are.
Because I'm gonna try this best. Okay. I'm not bored at all.
It's basically like since that is considered on the top. It's parallel to.
Here we go, just wait, here we go. So we're gonna watch Austin's handle, but don't break it, please, okay? So here we go, this is Superman up in the air, okay? The first G is just on this flat plane right here, okay? Which makes this distance right here. So then his forearm is gonna be your air velocity. The idea though, for this second triangle though, you need the connected sides.
Oh, okay.
You see what I mean? So it's, I don't know. Okay, but the idea is that you need, that's all I can say, you need the connected sides. And that's, sorry, that would have been probably better next time. It's done now, so we'll just do it go. Okay. All right, yeah, go ahead.
Why do we have to find those Cartesian vectors?
I just threw that in there because it's very possible on your homework or on your assignment I could say find the X, the Y, and the Z components. Okay, I could say that. So, and in the textbook it's part of the solution they had them in that form. So if it's easier to figure out going this way, really, if it's easier to figure out doing with the X and Y and Z components, then we'll do it that way. Okay, go ahead. Okay, good question for this one. Here we go, guys. We're going to talk about direction a little. Thank you. We're going to talk about direction in a little bit on actually one of the next questions. But because this question said find the magnitude, or I change it here to find the magnitude, that's just the distance. That's all it's going to be then. Okay. And because the problem is with direction is that it has to be relative to something. Like if I say find and measure an angle, in 3 dimensions, it's not just like it's flat, like it has to be compared to something else. So it's very difficult to find an angle for it, right? Like it's already sort of given us the angles. Well, yeah, it's going to be, well, not this one, but there's one I had north 18 degrees west. Well, that's relative to north, south, east, west, and then the elevation, but it has to be relative to something, right? So 99% of the time, actually probably 100% will just ask for magnitude. Yeah. No, I don't think so. I'm trying to think. I can't really envision that. All right, I'm going to start with 26B, and let's see if I remember how this one went. 26B, this is page 399, I think. It was 399, wasn't it?
Yeah, no, 399.
Okay. 26B said find was this written down correctly?
Yeah, it's like the
Adam?
5 resultant and then 35.
Okay. So here we go. I'm going to show you how to do this one, because this one, please put a star beside this one if you didn't quite get it, because there's a new thing. Now, can somebody please be brave and tell me how to find an angle between two vectors? It's a general equation. Go ahead. Right on. Okay, now here's the problem that I have with this question. I lost it. It's dropped here somewhere. So let's see. Oh, thank you. Okay, so the problem that we have with this is that we found out from the previous question that we had magnitude of u was 58.7 or something? 58.7. That's all we knew, right? That's all we know. There's a few other things we can get in there. If it's a 35 Newton vector, what's the magnitude of that going to be? 35. All right, now this is the part I want to make sure everyone's with me that didn't get this question. Okay? Yeah, go ahead.
Where did 58.7?
That came from part A of the question. I just skipped that part, so that's where that came from, okay? Now, here's the thing. We need to get for this one, for u dot v, we actually need to get the vectors in component form, okay? So, what are the components, when you add those three first vectors together, what's the components of vector u going to be then? Well, what's the x component there? You guys stay with me here, please.
25, 35, 40.
And this is the aha moment for that question, okay? Because you're given that the x value, when you add together a 25, 0, 0, and then a 0, 35, 0, and then a 0, 0, 40, the resultant's going to be 25, 35, 40, okay? Vector v then should be,
Are these numbers just in the textbook?
yes,
Okay.
yeah, of course you did your homework last night, so you're aware of all these things, right?
I mean, experience.
Okay, 0, 35, 0. Okay. So now we have two vectors, and this is what I was trying to say to Haley before about finding the angles between things. You have to have two vectors to find the angle between. So now we have, and this is a tricky part for this one, we finally got the angles, that we're, or the vectors that we're going to use, so we can do this. So we're going to say then cos theta. Who would I pick on in a while? Brad, I'm going to pick on you, and you're going to answer this one. How do I dot two vectors, please? Brad, sorry? Brad, okay. You just had lacrosse practice, so I'm not going to blame you. Okay, you just had lacrosse practice. You probably got hit by somebody in lacrosse, so I get it. It's mean. I say that to football players. How many times have I said that to you over the years? A lot, right? So I no disrespect. Somebody help me here. James, how do I dot two vectors? Oh, guys, come on, hurry, got two vectors. Haley, go ahead.
You do like X.
Yeah, the x times the x, the y times the y, and the z times the z.
So technically it's just 35 squared.
It is just 35 squared, okay? Times, so we have 58.7. And so we got an angle for that. And did you get an angle for that, Jennifer? Yeah. 3.4, which is what it should have been. Okay, if this is mysterious to you, what just happened, okay, we have to make sure we can tackle stuff like this. 1, 2, okay?
Okay, so problem is having, is it like the bottom half of the thing, like magnitude, that we do like the square root?
Yeah. Part A was a square root though. Part A said find the magnitude of u, so we already had it from part A, so I need to do that. Okay. Yeah, go ahead.
No,
Good?
never mind, I get it.
Sort of, yes?
No, I was just like, why didn't it 35 there?
Yeah. 1, 2. Okay, so good question. Here we go, guys, please. What happened was part A of the question said the magnitude, find the magnitude of u. That's what part A said. So we just stole that from part A to save ourselves some time. Jason, question? We're good? Yeah. 36. Can I start my lesson and then if I have time at the end we'll do 36? Okay? I'm going to pause this. If not, can somebody put a big circle around 36 and we'll do it on Monday? Okay? Somebody remind me.